Am I live? I'm live. Okay, here we go. So today we're going to talk about sequences and series. What the heck are those? So 4, 27, 21. Okay, all a sequence is just a list of numbers. A list of numbers in order. Okay, when I say order, I think you're going to see what that means here in just a second. Okay, a list of numbers in order. Okay. This stuff. Okay. I guess I'll just use this in order. Okay. So example. If I had 2 and 12 and 22 and 32 ... I think you can probably see that there's a definite order to that, right? Just add 10, add 10, add 10 each time. This particular one is called an arithmetic. Infinite sequence. Arithmetic because you're adding 10, adding 10, adding 10, and that's where the term arithmetic comes in. Arithmetic means you're just going to continue to add and add. Infinite means I got the ... right? So it goes on forever. That's easy. And it's a sequence. So a sequence is just the list of numbers in order, okay? All right, that's pretty easy. You guys agree? Nothing hard about that. So example 1, let's create the first 5 terms of the sequence. A of n equals 3n plus 1. So if we're going to create the first 5 terms, we're going to let n equal 1, 2, 3, 4, 5. Okay? And we're going to just plug in 1, 2, 3, 4, and 5. So first of all, A1. Okay, A1, we call it A1, which is our first term, is simply going to be 3 times 1 plus 1, because I'm plugging 1 just into the formula. So I'm plugging 1 into the formula, okay? Which makes 4, right? So A1 is 4. So we say A1 is equal to 4, all right? A2 would be 3 times 2 plus 1. So then A2 is 6 plus 1 is 7. A3 would be 3 times 3 plus 1, which is 9 plus 1, so A3 is 10. A4, well, that's easy. 3 times 4 plus 1, right? Which is 12 plus 1, which is 13. Okay, you guys see a pattern yet? They're going up by 3s, right? And that's where this 3 comes in. A5 then obviously is 3 times 5 plus 1, which is 15, plus 1, which is 16. So A5 is 16. So what we can do is list it as our answer. So I'm going to go ahead and say first 5 terms is going to be 4, comma, 7, comma, 10, comma, 13, comma, 16. Okay. This is a finite arithmetic sequence. Finite because it doesn't go on forever, right? Finite because there's only 5 terms. Arithmetic because it looks to me as if we're adding 3 each time. So add 3, add 3, add 3, okay? Finite arithmetic sequence. Okay, thumbs up. Now, example 2. Let's see. I want you to go in your journal and let's take a look at these 3 formulas, okay? So there's 3 formulas in your journal on page 198. Okay, so go to page 198, and there's 3 formulas we want. Okay, The one I'm mostly concerned with for us is this one here. I squared, okay? I squared is equal to n times n plus 1 times 2n plus 1 all over 6. What does this mean? Okay, example on this one. Well, in our example, in our notes, we're just going to do the first 5 terms, okay? In our notes, we're going to just do the first 5 terms. And so I'm going to come back to this, okay? I'm going to come back to this because I want to look at this, okay? So in our notes, if we go into the first 5 terms, then I can plug in 1, then 2, then 3, then 4, then 5, right? So A1 for us would be plug in 1. I'd have 1 squared plus 2 times 1 plus 1 makes, let's see, 1, 2, 4, right? A1 is 4. A2 is going to be a 2 squared plus 2 times 2 plus 1, which makes, let's see, 4. 4 makes 8, 9, right? A3, which is going to be a 3 squared plus a 2 times a 3 plus 1. Let's see, that's 9 plus 6 is 15. Is that right? 9 is 15 plus 1 is 16. A4 is going to be 4 squared plus 2 times 4 plus 1. What's that? 16 plus 8. If I make a mistake, will you guys tell me, please? Plus 1, and I get 25. Weird, huh? And then A5, 5 squared plus 2 times 5 plus 1, which is probably 36. There's a reason for that. Okay, there's my first 5 terms, okay? I just created it. Now, this one's not arithmetic. Not arithmetic. Turns out it's the squares, isn't it? Square terms, okay? It's squared terms. Because 4 is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, because this would have factored into an n plus 1 squared if you saw that. But I'm the only math nerd in here enough to see that, right? Okay, how am I doing so far? Am I doing okay? All right, now, example 3. Create a formula for this sequence. And then find the 20th term. Well, my formula is going to look like one of these. It's going to look like a of n equals some blah, 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 or a of n equals some blah, blah, blah. So we need to actually create the formula, okay? So let's start off with this. Let's start off with a of n equals, okay? So what do you think's going on? What do you see that's going on? I go from 1 to 6 to 11 to 16. Adding 5, exactly. Now this is weird, and I'm going to go back all the way back up to here. And if you noticed on this one, we're adding 3. Do you see that? But it's 3n. Because all addition is, all multiplication is adding groups. Does that make sense? So this 3n gave us plus 3, plus 3, plus 3, plus 3, didn't it? So Abby, you're right. If this is like adding 5, let's start with a 5n. Okay. Now, all right, let's see. If I plug in 1, I get 5. If I plug in 2, so I'm going to use my, so if I plug in 1, I get 5. I plug in 2, I get 10. Plug in 3, I get 15. I'm not making this, but I can make an adjustment to this. If I go 5n and I go minus 4, would that make this formula? Let's try it. So if I plug in 1, I get 5 minus 4 gives me 1. If I plug in 2, I get 10. 10 minus 4 is 6. Good. If I plug in 3, I get 15. Minus 4, I get 11. Good. I think I've made the formula, haven't I? See how this formula would work? Okay, now I'm going to give you something, okay? So here is, we're going to learn this tomorrow, well, Thursday specifically, but a formula, a of n equals, ready? Now we're going to learn this specifically on, we're going to have a1 plus n minus 1 times d, and this is our formula for making an arithmetic formula, okay? And this is a formula that will work to make arithmetic ones, okay? So write that down. It might help you. We're going to learn this more specifically on Thursday, okay? Are you guys ready to turn it over? Not yet. I'll wait for you, okay? This would make this. A1 would have been the 1, n is the variable n minus 1, and d is the difference, which is 5. So if this would have been a of n equals a1 plus a n minus 1 times 5. And if you simplify it, it would have given you this. You wouldn't have to use your brain, but I like to use my brain. Okay, ready to turn the page? All right, now. Oh, yes. Oh, I didn't do that. Oh, Ellie, thank you. Let's do the 20th. Let me finish my job. A of 20, thank you, Ellie. 2 ways to do it. One is just, thank you so much. One is to keep adding 5, adding, which you can, right? You can just keep going, adding 5, adding 5, adding 5, until you get all the way to the 20th term, right? Or, let's just use our formula, okay? That's why we make a formula, right? We can just keep going, 20, 20, 20, 20, 20, 20, keep going all the way until we get to the 20th term. Add 5, add 5, add 5. Or, how about A of 20 is 5, 20th term, plug in 20, minus 4, which is 100, minus 4, which is 96. Thank you, Ellie. I almost forgot to do that. Somebody's awake. Ellie's like, barely, Mr. Davies. Anyway, okay, turn the page. Okay, now, create a formula for this formula, okay? 1/4, 2/4, 3/4. So A of n equals, what do you think's going on? I'm going to help you. So n is always these numbers. We are always going to plug in 1, 2, 3, 4, dot, 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 dot. Okay? N is always the set of whole numbers. No, natural numbers. So what I have is on top is just 1, 2, 3. So I'm going to have an n over 4, 4, 4 over 4. This formula would make this sequence. Plug in 1, plug in 2, plug in 3, plug in 4, right? It would create this formula, okay? So then if we want the 10th term, that's easy. We can either just keep making it, or I can choose my formula. Say A of 10 is equal to, well, plug in 10 over 4. 10/4 or 5/2 if I reduce it, okay? Okay, example 5. How am I doing? All right, again, n is these numbers. 1, 2, 3, 4, dot, 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 dot. Okay, so there's 2 ways to tackle this. One is just to say, okay, let's just count up. So how many squares do I have? I got 4, right? So A of 1 has 4 squares. 1, 2, 3, 4. A of 2, let's see, A of 2's got how many squares? 1, 2, 3, 4, 5, 6, 7, 8. All right. A3, let's see. A3's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What do you think's going on? Yeah, it's always just going to be multiplied by 4, right? So we could say that A of n is equal to just 4n. What's going on theoretically is this. It is, and I'm going to show you, A of n is equal to a n plus 1 squared, because it's a square. But then we got to subtract out the whole, which is going to be an n minus 1 squared. And when you simplify all this, it turns out to be just that. Now, I want to show you one more thing, and that's in your journal, okay? So let's take a look at our journal, okay? And I'll wait for you. So go to that page 198, okay? Okay, on page 198, it talks about series. Okay, series. So a sequence, I'm going to write this up here, a sequence on page 198. A sequence is just a list. It's just a list of numbers, right? Just a list. But a series is where you add them all up. A series is where you add them all together, okay? So the difference is, instead of a list of numbers, you get a single answer. Now this weird thing, this weird thing here is called sigma, or summation notation. Okay? You see this weird symbol? This weird symbol right here means add them all up, okay? So you got to create it, then add them all up, okay? So they give us the first example. The first example is this. If you're given this as an example, you're like, what the heck? What does this mean? Well, this symbol means make the terms, then add. Okay, so I'm going to plug in 1. I'm going to plug in 2. I'm going to plug in 3. And I'm going to plug in 4, because we're going to plug in from 1 to 4. Start at 1 and go to 4. So we're going to plug in. So we're going to plug in 1. So I plug in 1, I get my 2. I plug in my 2, and I get my 4. Plug in 3, and I get 6. Plug in 4, and I get 8. So we're going to plug in. So plug it in. Plug in 1, 2, 3, 4. Because it's these two numbers. Start at 1 all the way to 4. And once you do that, you've made 4 terms. And then you just add them up. What is 1 plus 2 plus 1 plus 4 plus 6 plus 8? I could probably do that without my calculator, but you know. 6 plus 14, I get an answer of 20. So the sum of this is 20. Yes, Ellie?
So what are you plugging in the different numbers for? Are you plugging in for I?
Let's take a look at, let's do this example. Let me make another example for you, okay? Let's do sum n equals 1, 2. Let's make it pretty easy. Let's do an easy one. Let's do 5 of, let's go a 3n plus 1, okay? That's a question. That is a question. The question is, when you plug in 1, 2, 3, 4, and 5 into this, you'll make 5 terms. I'm going to plug in 1, I'm going to plug in 2, I'm going to plug in 3, plug in 4, I'm going to plug in 5, and then I'm going to get 5 terms, and then I'm going to add them all up, okay? So, A1 is 3 times 1 plus 1, which is 4. A2, because I'm plugging 1 through 5. Does that make sense? 1 through 5. A2 is 3 times 2 plus 1, which is 6, which makes us 7, okay? A3 is 3 times 3 plus 1, which is 9 plus 1, which is 10, okay? A4, plug 4 in. Plug 4 in is 3 times 4 plus 1, which is 13. A5 is 3 times 5 plus 1, which is 16. Okay, now, I'm going to stop for a second and let you catch up. This is a list of numbers. This is a list of numbers. We want the sum. So this big symbol means we want the sum, okay? So we want the sum of all this. So, all right, add them all up, all right? 4 plus 7 plus 10 plus 13 plus 16. I get an answer of 50. So the answer is 50. All right, almost done. If you want just a list of numbers, it's called a sequence. If you want to add them all up, it's a series. This symbol means add them all up. The A of N symbol means just list them, okay? All right, let's see if I can work with you on the homework, okay? I have to stop. Stop. Stop.